Move to question number 7. So a machine uses apples to extract their juice. The volume of juice JML extracted from 1 kilogram of apple is modeled by a normal distribution with a mean mu and standard deviation sigma. Given that mu or the mean is 500 and sigma 25, use standardization to show that probability of J greater than 510 is equal to 0.3446. Calculate the value of D such that probability of J greater than D is equal to 0.91. Right. So here, to get a clarity on this, I will draw two sets of normal distribution graph. One is for standard normal distribution graph and one is for the actual graph, for actual case. Normal distribution graph. This is standard normal distribution graph. We know that it's a bell-shaped curve. For this bell-shaped curve, the area under this curve is always 1. So here in this case, actually the mean is 500. But for the standard normal distribution graph, that mean bring back to 0. So this is the variable J. Here the variable is expressed as Z. So we need to find the probability of J greater than 510. That is what we need to show it as 0.3446. So 510 is above 500. So here what we should do is we need to find this area. So here this 510 we will be bring back to a variable Z1. So what is this Z1? Z1 is equal to whatever be the value we need to change, that is 500 minus 500 divided by the standard deviation of this is 25. So this is 0.4. So that means probability of J greater than 510 means it is actually probability of Z greater than 0.4. Probability of Z greater than 0.4 is 1 minus probability of Z less than 0.4. See, probability of Z less than 0.4, we will get this from the table that is provided in your data sheet. Because all these values are given for less than. If this is the normal distribution curve, if this is our Z1, if this is the area we need to find, this area we can calculate from this probability of Z less than Z1. That is what we are getting from this step. So that is why we modified this, because our aim is to find probability of Z greater than 0.4. From the table, it is not possible to calculate. So we converted into 1 minus probability of Z less than. Because why we are taking 1 minus? Because the total area is 1. And if you want to find this area, from the entire area, you subtract this. So 1 minus probability of Z less than 0.4. Now you see, for 0.4, what is the probability? 0.6554. So 1 minus 0.6554. And what we will get? 0.3446. Hence, short. Now move to the B question. So in the B question, they are asking to find the value of D. Calculate the value of D such that probability of J greater than D is 0.9192. Again, we will draw the normal graph and standard normal distribution graph. So here, our aim is to find the value of D because this is the J distribution, this is the Z distribution. Our aim is to find the value of D such that probability of J greater than D is 0.9192. See, you know that the D value has to be a negative. What is the reason? Because this area and this area equally divided. So that means after mean 0.5, before mean also 0.5. So probability of J greater than D is 0.912 means definitely D is somewhere here. Why? So that this area exceeds 0.5. So this area is 0.9192. I'll use a different color to clearly represent that. Probability of J greater than D. So this entire area is 0.91. So there will be 1 D. So if you are converting this into a standard normal distribution graph, there will be one Z value. This is one Z1 value is there. So this Z1 value must be a negative Z1 value. Okay. Such that this area is also 0.919. Clear? So we can say that probability of J greater than D is exactly equal to probability of Z greater than negative Z. Here this variable is negative. Why? Because it is below mean, right? Now, because this mean is always 0. Now, you think about this situation. For the same graph, this is our Z1, negative Z1, and this is the mean, mu equal to 0. So our aim is to find, this Z1 value. So how will you find this Z1 value? By symmetry, we can say that if this is negative Z1, this is a positive Z1, such that this area and this area are exactly equal. So what is probability of Z less than negative Z1? That is 1 minus 0.9192. So what is 1 minus 9192? That is 0.0808. So this area is 0.0808, and therefore this area is also 0.0808. So we can calculate the positive Z1 from the table. How? Probability of Z greater than positive Z1 is also 0.808. Probability of Z greater than Z1 means it is 1 minus probability of Z less than Z1. That is 0.0808. So that means probability of Z less than Z1 means it is 1 minus 0.080. Again, we will get 0.9192. So probability of Z less than Z1, we are getting it as 0.9192. Now you go to the table and find what is the Z1 value. For what value of Z, we are getting 0.9192. For what value of Z1, we are getting 0.9192. It is happening for 1.4. So the Z1 value is 1.40. But in actual, our Z1 value is negative 1.40. Why? Because this is in the actual negative side. So this D value is mapped to Z1. So how we are mapping this to Z1? We are using the coding equation. What is that? D minus mean, that is 500, divided by standard deviation, that is our result. And Z1 is negative 1.40. That is D minus 500 by 25. Then you try to make D the subject. So negative 1.40 multiplied by 25, then plus 500. And the value, we will get it as 465. So answer for this question, we can say the D value is 460. Got it? So here, this value is 460. Negative 1.40 mapped to 460. So that is the idea behind this question. Okay, now move to the B question. Calculate the probability that, okay, Sen randomly selects 5 bags, each containing 1 kilogram of apple, records the volume of juice extracted from each bag of apples. Calculate the probability that each of the 5 bags of apple produces less than 510 ml. So in each case, what is the probability of juice less than 510? It is 1 minus probability of juice greater than 510. That means 1 minus 0.3446, because we already got probability of J greater than 510 as 0.3446. So 1 minus 0.3446, that is 0.6544. So this is happening in each bag. We have altogether 5 bags. So in the first bag, juice is less than 510, and in the second bag also juice is less than 510, and the third bag also the juice is less than 510. In the fourth bag also the juice is less than 510, and in the fifth bag also juice is less than 510. So what is the answer? 0.6544 multiplied by 0.6544, 0.6544 multiplied by 0.6544, multiplied by 0.6544. So that is the answer for this question. So if you are doing so, we are getting 0.1209. And if you are rounding to 3 significant figures, 0.121 is the answer. Now, C part of this question. Following adjustments to measure the volume of juice RML extracted from 1 kilogram apple is such that the mean is 520 and the standard deviation is K. So this is a different scenario. This is the normal distribution curve, and the mean is 520 and the standard deviation is K. And the standard deviation is K. Now what is our question? The mean is 520 instead of 500. Okay. So what is our question now? Then randomly selects 5 back. Okay. So to avoid this continuous scrolling, I will keep this question directly there. Okay. So I'll keep this question here. So send randomly selects 5 bags, each containing 1 bag. Okay, that we already did. Following adjustments to make machine the volume of use RML. So this is the distribution RML extracted from 1 kilogram apple such that mean is 520 and the standard deviation is K. The probability of R which is less than small r is 0.15. So that means, we know that this area is, this is the mean. Mean is 520. So after the mean, the area of this is 0.5. And before the mean, the area is 0.5. So R is less than 0.15 means obviously somewhere here is the smaller, such that this area is 0.15. What is the reason? Because 0.15 is a value contained in 0.5, correct? Suppose if this R was somewhere here, definitely the probability must be greater than 0.5. That is the idea. Okay. So now, probability of R which is greater than 3R minus 800 is 0.005. So greater than 3R minus 800 means this area greater than. So that means somewhere here is that point. Which one? 3R minus 800. Why? 3R minus 8 greater than this area is positive value, right? So suppose if this value is somewhere here, definitely that value must be greater than 0.5. Here this value is not greater than 0.5. So that is why we are placing that 3R minus 800 over there. So if this is the case, if we are in a position to find the value of R and K, so how will you do this? We have to draw a standard normal distribution curve, such that this is my Z2 and this is my Z1. This area is 0.15, this area is 0.05. So how will you model this Z1? Z1 we will say that it is equal to the respective R value minus mean. Mean is 520 divided by standard deviation, that is K. How will you model this Z2? Z2 we will say that the respective value, that is 3R minus 800 minus 520 divided by K. But it's so sure that this Z1 is negative in nature. So Z1 has to be negative. So this Z1 has to be negative value. Now, how will you answer this question? How will you find the value of R and K? We need to develop simultaneous equations. We have two unknowns. So we need to develop two equations to find the value. So somehow we should find the value of Z1 and Z2. Okay. So this is the idea. So I draw separately the standard normal distribution curve. So this is our negative Z1, such that this area is 0.15. So there will be, because this is negative Z1, from the table we are not getting any negative value. So if there is minus Z1, there will be always a positive Z1, such that this area is 0.15. So probability of Z less than negative Z1 is exactly equal to probability of Z greater than positive Z1, and that is equal to 1 minus probability of Z less than Z1. So 1 minus probability of Z less than Z1 is 0.15. Therefore, probability of Z less than Z1 is equal to 1 minus 0.15. So that is 0.85. So now you calculate what is the value of Z1 for which that is giving 0.85. Go to the table. 0.85. So value somewhat nearer to is 1.0, because this is 0.845. This is 0.850608. So it is 1 point something, it is somewhat just less than 1.04. So for 1.03, the value is 0.8485. For 1.04, 0.8508. So our aim is to find the value for 0.85. So you can directly go do linear interpolation to get the value exactly, or else you can just approximate. So I would like to approximate it as 1.036. So the value of Z1 is 1.036. This is a positive value, but Z1 has to be negative. So that negative Z1 means it is negative 1.036. So we will keep aside this. Then we need another value, that is Z2. So this Z2, this area is 0. What is that probability? 0.005. Probability of this is 0.005. So probability of Z greater than Z2 is 0.005. So there is a percentage table. So if possible, you can just refer this table, and 0.005 you can see here. What is that value? 2.5758. So this table is actually giving the value for probability of Z greater than Z. See, the definition is also given. This is the second table, percentage point of the normal distribution. So 0.005, the probability, the value of corresponding Z is 2.5758. So the Z2 value is 2.5758. So now almost all the Z values we obtained. So minus Z1, what is the formula? Minus Z1. According to this, you refer this. What is the value of minus Z1? Minus Z1 is equal to R minus 520 by K. So minus 1.036 is R minus 520 by K. This 2. Z2 we already got 2.5758. That is 3R minus 800 minus 520 by K. So please rearrange this. Minus 1.36 R, no, K. is equal to R minus 520. Therefore, the value of R is minus 1.036K plus 520. The value of R is minus 1.036K plus 520. Here, cross multiply. 2.5758K is equal to 3R minus 800 minus 520 is 141320. Minus 800 minus 520 is minus 1320. Now, you can bring this to this side. So 2.5758K plus 1320 is 3R. Now you solve these two simultaneous equations to find the value of R and K. So if you are solving these two equations, because you can do elimination, substitution. So this R you can replace here. So 2.5758K plus 1320 is 3 times negative 1.36K plus 520. So 2.5758K plus 1320 is negative 3 times negative 1.036. That is negative 3.108K plus 3 times 520. That is 1560. Then you rearrange it. 2.5758K plus 3.108K is 1560 minus 1320. 2.5758 plus 3.108. So 5.6838 is 1560 minus 1320. 240. This K. So the value of K is 240 upon 240 upon 5.6838. So the value of K 42.23. So if you know the value of K, now you can easily find the value of R. So R value is equal to minus 1.036 times K is 42.23 plus 520 minus 1.036 multiplied by, so here you have to use the non-rounded value, that is K is 240 by 5.6838 to get an exact answer. 240 divided by 5.6838 plus 520. So the answer is 476.25. So value of R is 476.25. So what is the answer for this question now? We got this answer. So R value is 42.23 and not R value, it's a K value. And R value 476.25. So that is the answer for this test. It's slightly time consuming, but if you are investing time, you can easily get that answer. But while answering these kind of questions, it is advisable to keep this question exactly in the last part. Okay, so if you're getting time, you attempt this question. Otherwise, you will complete rest of the other questions and then you try to approach this question. At least do A and B part. Okay, so that's about this question.